very imprecise. And in the results we get for databases exact results, always correct in the formal sense. So if you want to recover something, they'll say there are 10 records, there is no record, there is X number of records. And it's 100% correct what they are saying. I mean what that engine is saying, right? In databases. When you are over here, it's not true. Sometimes relevant, often not. So it retrieves, if you see it, I mean in Google you see many million records in return. But only few of the records make sense to you. And at times you need to change the query, right? In order to get what you are looking for. So that's the difference between these two. Interaction with system. One shot query. You don't need to put 2 times if you know exactly what you are looking for in databases. Here interaction is very important. So maybe a person like me is writing a concept in a way that I receive something on the first time. But there are people who do not get the answer to the same question when they are writing the same query but in different language. So it's not that true, right? So interaction is very important and it's very dependent upon user as well. Other issues. Okay, in databases there are much concern about concurrency, recovery, atomicity. All are very critical to them. So they say my database is good, my engine is very good, and then they start saying things about these 3 things, for example. Or if your database is correct, atomicity has to be there, otherwise it's bad. So these are their major concerns or focuses. Over here these issues are not that important. Why? Because for example atomicity you may require it, but it's not that highlighted. You may require concurrency and recovery, but it's not that highlighted. What is highlighted the most here is user satisfaction. You are retrieving actually the important results. I mean, whenever you say I want to search for example on cricket, and you go onto Facebook, on Google or Bing, you see several results, many results, but maybe you are interested in few of them, and those are important results, right? So the main catch over here is show the important most result to the user in order to maximize this user satisfaction. So that's where, that's the difference between these two. So here other issues are that, and these such issues are downplayed. They are not that important. I believe from here Arjuman would like to continue, right?
We all saw the challenges of information retrieval and how databases are different from the information retrieval problem. Information retrieval is very different from the traditional paradigm. So, what's the main challenge? Can anybody tell me? It's from what Jasadiv said in 2 slides. What is the main challenge in information retrieval? Why is it a hard problem?
To give the exact information, what could satisfy the user.
Exactly, the user. The user is a human being, and human language is natural language, which is very rich. We do not have queries like select all from this list. So the interpretation of the query and also the data, the documents from which we are retrieving, they are not straightforward like in a database. So we have fuzzy text, unstructured text. That's the main challenge. So what do we need? We need a model. Just like in database we have models, ER model. There was a whole evolution of models. We had the network model, and then came the ER model, which is popular up to now. Likewise, for information retrieval, there is need for making the computer understand the document and the query on a computational level. And that's how information retrieval can work. But first, What's a model? How do we define a model? A model is an abstraction, a construct designed to help us understand some complex system. And what is that complex system? In our case, it's an information retrieval system, a search engine. It's just a particular way of looking at things. The main theme underlying any model is that it works on simple assumptions. Of course, the problem is very hard, but what do we learn in algorithms to solve hard problems? There's a very basic, simple rule. Break that problem down into simple problems and then divide and conquer approach, solve the hard problem. So likewise we are doing here. We break it in the model, we adopt simplified assumptions. There are different types of models. In databases we had these conceptual models for ER model, all these are conceptual models. Then we have physical analog models in engineering, in physics. Like for building structures you have a toy model. Here in information retrieval we got mathematical models, which I'll be covering through this lecture. So pay attention, otherwise you won't be able to do the assignment. There will be 2 assignments, this one and another one I'll upload by Monday, and that's a programming assignment. Okay, so what is the major simplification I talked about? Bag of words, as introduced in the outline, bag of words. What do we do is that we consider each document as a bag of words. What do I mean by bag of words? Can anybody throw some light on that?
We have a bag full of words and we have to...
Exactly. We just consider the document as it's a bag of words. We don't care about the order or the structure of the words. So, and also the queries that comes to the search engine is considered as a bag of words. So this is a great simplification. The order in real world is important, but we are simplifying this to make the model easy, to make the information retrieval problem easy, and you'll see how wonderfully it works. But still, the question remains, how does a bag of words of simplification help us to match the documents with the queries? So, can you see here, suppose there is a document, McDonald's slims down fudge, and here's the content. There are some words appearing in this article. 14 times we have McDonald's, 16 times we have said, 12 times we have fat, 11 times we have fries. So this is bag of words. Intuitively we can see, yes, it will work. We know how many words are appearing, how many number of times. So if someone puts in McDonald's, this should be a relevant document for the query McDonald's. So intuitively, yes, this can work. Okay, so but how can we represent the bag of words in the computer? So here, our old friend from physics, the vector, comes into play. Why vector? Because it's, as I said, to make it computationally efficient. And for ease of manipulation, it's very easy to play around with vectors. Does anyone remember what is a vector? And how do we represent it in a computer? How can we? Vector is just a series of numbers, right? We can use linked list, we can use array, any data structure. Array list, anything. And every programming language has such a structure. So here, a very famous string from...
You're going to see that vector is some sort of data structure.
Yes, here you can say list. We say it vector because in information retrieval we borrowed the idea from physics. You can call it a list from the computer's point of view. We are saying it vector because as we'll proceed with the lecture, you see most of the concepts of physics are being applied to solve the information retrieval problem. Okay, so this is a famous string from computer science. The quick brown fox jumps over the lazy dog rat. And we have vector representation. Bag of words representation for this is like this. So this one represents bat, this one represents brown, this one represents dog, So we arrange it in alphabetical order. First, all the words